Hi friends, today we are talking about garbage collection in Java. Choosing the right GC implementation may help you boost the performance of your application. Hotspot JVM offers not one, but 7 available collectors, all fit for different applications or performance requirements. So let's look at all of them. Well, first, before going any further, let's refresh the Java memory model a bit. So one of the functions of Java garbage collection is to maintain young generation and old generation. So as a rule, most objects die young, but if they don't, they are moved into the old generation. When the garbage collector collects the young generation, it's called the minor collection. And when it wants to clean up the old generation, it's called the major collection. Not all Java garbage collectors maintain separate generations, but we will discuss that further on. Serial GC is the oldest and simplest Java garbage collector. It freezes all application threads and works in one thread to perform the collection. It is suitable for small client-side applications without strict requirements to small pausers. But there is a catch with this collector. If you limit your application to 2 GB of RAM and less than 2 processors, then the serial GC will be used automatically, even if you specify another collector. So be careful about that. Parallel GC is also called a throughput collector. It also freezes all application threads, but works in multiple threads to perform the collection. And by default, it uses multiple threads to collect the young generation and old generation. You can tune this collector. You can set, for instance, pause times, pause intervals, and the time the application spends on garbage collection. Concurrent Mark Sweep GC is designed for shorter pauses, and it uses multiple threads to perform the collection. But it is suitable for applications that can afford sharing the processor resources with the garbage collector while the application is running. CMS GC was deprecated in Java 9 and removed in Java 14. G1 GC was designed to replace CMS GC. It is now the default Java garbage collector. G1 GC tries to provide a good balance between throughput and latency, and it is good for applications that run in multiprocessor environments and for applications with large heaps of 10 GB and more. G1 means garbage first. Just like the collectors I described before, it works with young generation and old generation, but it splits the heap into multiple equal-sized regions. And before performing the collection, it performs the global marking phase concurrently with the application and determines which objects are reachable or live. Then it reclaims space in regions that are mostly filled with garbage, thus freeing more memory. This is why it's called garbage first. G1 GC reclaims space using evacuation. It means that it copies and compacts live objects from one or several regions into new regions. This helps to avoid memory fragmentation. You can also tune this garbage collector. You can set pause times, pause intervals, and so on. ZGC was first introduced in Java 11. It is a scalable low-latency collector, which is good for latency-sensitive applications with very large heaps of terabytes. ZGC performs the expensive work concurrently with the application, and the pause times are never longer than 10 milliseconds. This collector requires minimal configuration. In most cases, you just have to set this heap size and you're good to go. In the beginning, this collector wasn't generational, but in Java 29 it became generational by default. So it means that it maintains young generation and old generation and collects young objects more frequently. This improves heap memory overhead and garbage collection CPU overhead. Shenandoah GC is also a low-latency garbage collector. It was introduced in Java 12. It performs most of its work concurrently with the application, including the concurrent compaction, and so the pause times are not directly proportional to the heap size. Just like ZGC, this collector is good for latency-sensitive applications with very large heaps of terabytes. Oracle Java doesn't ship Shenandoah GC, but it is available with the major OpenJDK distributions, including Librarica JDK. Epsilon GC is a very interesting Java garbage collector. It doesn't actually perform any garbage collection and only allocates memory. Why would you need a garbage collector that doesn't collect any garbage, right? But actually it has a purpose. You can use it for performance testing and see how fast your application will run without the collection. And also you can see if there are any performance bottlenecks not induced by the garbage collection. Epsilon GC is also suitable for applications that almost don't produce any garbage or don't have time to leave any garbage. In these cases, the program may actually run faster without the garbage collection. There's another interesting feature of Epsilon GC. It was introduced as an experimental feature and it will remain experimental forever, so that you don't accidentally use it in production. So, to enable Epsilon GC, you have to explicitly enable the experimental features and then switch on this collector. Want to know more about Java garbage collection? Refer to the article in the description box below.